Week 6 of our lockdown here in the United Kingdom. I'm Chris Astill-Smith. I'm an osteopath, a naturopath and applied kinesiologist. I'm also Director of Research and Development here at Epigenetics Limited. I've been inspired to write this presentation by the recent excellent webinars given by Wally Schmidt and Kerry McCord, and most recently by Tyrone Mincy from New Jersey. I'm going to call this talk Optimizing the Immune System Against the COVID-19 Virus. Okay, so optimizing the immune system against the COVID-19 virus. So let's start by looking at the structure of the virus itself, which I'm sure you're very familiar with by now. So here we see this nice picture of the RNA coil with the virus genetic material itself. But more important is this envelope around the outside of it, which consists of the spike glycoproteins here, which is what makes the entry into the cell, and the envelope, which is combined of a combination of lipid and protein. And this is the vulnerable bit of how we can attack the virus itself. So looking again at a different picture of the virus, we've got the spike protein here, we've got the membrane proteins within the membrane itself, within the envelope, and the envelope composed mostly of lipids. And here's the dreaded spike protein itself, which makes the entry as we see through the ACE2 receptor. Now, my introduction to trying to find a diagnostic entry into the COVID-19 was using spectroscopic emissions. So every living and non-living compound, whether organic or not, emits a spectroscopic emission when it's activated or heated. We see this with the orange streetlights that are turned on at dusk time in a particular location. So these lights contain sodium gas, which has been a spectroscopic emission, like the one down here on the left. So this is the spectroscopic emission when the sodium gas is heated. And we see there's a selection of colors from the violet end of the spectrum to the red end of the spectrum. But what the human eye sees is a combination of these colors, which gives us this orange glow. However, when all these different colors are layered together, humans see the bright orange glow when the light is switched on, which can be measured as a single monochromic emission. The human eye perceives light from the violet end of the spectrum, as we know, from 385 to the red end of the spectrum, which is at 645 all the way through to 770 nanometers. So my finding is that the COVID-19 has a spectroscopic emission of exactly 633 nanometers, which is in the orange spectrum towards the red end, but certainly within the orange spectrum. You can print off this either on a piece of paper or best on an acetate sheet, or you could put it onto your mobile phone. If on paper, place it colored side down on the patient, or the patient looks at it directly with their eyes. This acetate is now available from Epigenetics at the website epigenetics-international.com. Thus, if a patient weakens in the clear to the specific colored acetate, you might say that they currently have COVID-19, but of course never base a diagnosis on one finding alone. You must follow government guidelines in such cases anyway. I've tested this remotely using hair samples of known cases of COVID-19, and they weaken in the clear if the virus is or still active, regardless of the patient's symptoms. Here we see a picture of the 633 nanometer acetate on a patient. Most people do not weaken in the clear to this acetate, as of course they're not currently infectious. However, most people, when they do not weaken in the clear, do weaken when the acetate is challenged whilst therapy localizing the current one-time or mu time point. The one or mu time point is the couple to the meridian's alarm point to the now time. So if we look here, we'll see that the lung time at the moment with summer saving time is 4 till 6 in the morning, and therefore the couple is the large intestine. So the large intestine alarm point would be the one time. So in this case, the heart alarm point here shown is the one time against the small intestine now time. So the now time would be between 2 and 4 in the afternoon. And therefore the one time is the couple, which is the heart alarm point. This does not mean that they had COVID-19, but if they were exposed to it, you can find what optimizes their immune system against it. From this weakness, you can now discover exactly what the individual requirements are for improving the immunity against the virus. For instance, what we find is vitamin D3, zinc, vitamin C, probiotics, coconut oil containing monolaurate, vitamin K2, reduced glutathione, amongst others. So updating the diagnostic approach, this diagnostic approach to COVID-19, using the preceding protocol, you've been able to assess a range of nutrients to support you, your family, and your patient's immune systems. Most of the people I have put on vitamin D3, zinc, and the sodium ascorbate for vitamin C have so far not contracted the virus. I've had several people who have tested positive, however, but have had mild symptoms and recovered within a few days by taking those particular nutrients. However, there appears to be another aspect to the reason why some people are affected worse by the virus than others. My observation is that patients who do not weaken the clear, but only with therapy localization to the one time, do weaken when challenged firstly with genetically modified soy, followed by the 633 nanometer acetate. The GM soy itself does not weaken in the clear, but when left on and then the acetate added, they do weaken. So if a person weakens in the clear to soy, then they probably have an intolerance to the soy. Here we see the 633 acetate with a vial of GM soy on, and if this combination weakens, then we know that we've got somebody who's very sensitive, predisposing to the virus itself, and the soy protein, as we'll see, is inhibiting the immune system. So this may mean that the GM soy is in some way facilitating the viral entry. Interestingly, organic soy does not create this weakening. 93% of the world's soya is genetically modified, but be aware that much organic is affected also by cross-contamination. Generic GMO soybeans, following expiration of Monsanto's patent on the first variety of glyphosate-resistant Roundup Ready soybeans in 2015, development began on glyphosate-resistant generic soybeans. Monsanto developed a glyphosate-resistant soybean that expressed Cry1AC protein from Bacillus thuringiensis and the glyphosate-resistant gene. Cry1AC protoxin is a crystal protein produced by this gram-positive bacteria during sporulation. Cry1AC is one of the delta endotoxins produced by this bacterium, which act as an insecticide. Because of this, the genes for this have been introduced into the commercially important crops by genetic engineering, such as soy, cotton, and corn, in order to confer pest resistance on those plants. Cry1AC is also a mucosal adjuvant, an over-immune response enhancer for human beings. It is a toxin that would have to be detoxified if ingested in humans, probably by conjugation with glutathione. In my patients positive to COVID-19, they show low in reduced glutathione and underexpression of glutathione S transferase, particularly the MCST3 gene. So microsomal glutathione S transferase, or MGST3, is an enzyme that in human beings is encoded by the particular MGST3 gene, which is on chromosome 1, the P arm, and resonates at 370 nanometers. Now, membrane-associated proteins in eicosanoid and glutathione metabolism family consist of 6 human proteins, which includes the microsomal glutathione S transferase 3, are involved in the production of leukotrienes and prostaglandins E series, both important mediators of inflammation. This gene encodes the enzyme that catalyzes the conjugation of leukotriene A4 and reduced glutathione to produce leukotriene C4. This enzyme also demonstrates glutathione-dependent peroxidase activity towards lipid hydroperoxides. Now here we see a nice chart of the arachidonic acid, the omega-6 fatty acid derivative, going mediated by lipoxygenase enzyme through to leukotriene A4, and then on to leukotriene C4, D4, and E4, progressively getting less inflammatory. Now, the CRY1AC toxin probably inhibits this enzyme here, which is glutathione S transferase enzyme, and requires glutathione to conjugate with the leukotriene A4 to make glutathione C4. And if this enzyme is inhibited or overloaded by the toxin, it'll shunt the leukotriene A4 into making leukotriene B4 with the addition of water. This shunting of leukotriene A4 to the formation of B4 is the most inflammatory of all chemical mediators, especially to the lungs. Leukotriene B4's primary function is to recruit neutrophils to areas of tissue damage. Through it, although it helps promote the production of inflammatory cytokines by various immune cells. Drugs that block the action of leukotriene B4 have shown some efficacy in slowing the progression of neutrophil-mediated diseases. Now, cytochrome storm syndrome is a form of systemic inflammatory response syndrome and is an adverse effect of some viral infections, chemicals, and drugs. A number of deaths due to COVID-19 have been attributed to cytokine release storms. I thus strongly advise all people to strictly avoid all soya products in their diet at this time. Using the preceding challenge, you may find a need for supplementing extra reduced glutathione into their immune optimizing regime, along with the vitamin C, zinc, and vitamin D. We strongly suggest using a good source of reduced glutathione, well absorbed, such as the liposomal glutathione reduced that we manufacture. Here we see a list of soy products. So we have soya protein isolate, soya milk, soy cheese, ice cream, yogurt and flour, tofu, miso, natto, soyu, soya sauce, tamari, edamame, soya vegetable oils, tempeh, vegetable gums, broths and starches, hydrolyzed vegetable protein, textured vegetable protein, and soya molasses, hydrolyzed plant protein, monosodium glutamate, artificial flavorings and so-called natural flavorings, plum sauce, hoisin sauce and fish sauce, teriyaki sauce, instant gravy granules, bouillon cubes, okara, soybean butter, vegetable gums, gum arabic, gara gum, vegetable starches, soy lecithin, some cosmetics and lip balms, bean sprouts, mono and diglyceride thickeners, and mixed tocopherols derived from soy. Some other products may contain soy in part. These are candies, cereals, Asian foods, baked goods and baking mixes, chicken processed with chicken broth, chocolate, deli meats made with hydrolyzed vegetable protein, energy bars and nutrition bars, hamburger meat with soy protein fillers, hamburger buns made with added soya flour, ice cream, imitation dairy foods, infant formulas, margarine, mayonnaise, nutritional supplements, peanut butter and peanut butter substitutes, commercial sauces, gravies and soups, sweet bean sauce, sausages and hot dogs made with soya protein fillers, smoothies, vegetable broth and vegetarian meat substitutes. So interestingly, vitamin C aids in the recycling of glutathione, which is a very important tripeptide detoxifier at this particular time. The zinc cofactors the conversion of cysteine into glutathione and also activates, as we'll see, the ACE2 enzyme receptor. Vitamin D stimulates the synthesis of glutathione and also reduces the expression of gamma-glutamyl transferase, which inhibits the absorption of dietary glutathione. So here we see the cell, cysteine coming together with glutamic acid and glycine to make glutathione. Here we see glutathione S transferase, which is the main enzyme which takes toxins to link up or conjugate with the glutathione. And it's this one, the 1P 370 nanometers, which is the microsomal glutathione S transferase form, which is most effective with this particular soy protein. It's interesting also to note that in the UK, Britain's ethnic minorities of blacks particularly are 4 times more prone to death from COVID-19. Asians, who are 50% more likely, and also obese people, are suffering a vastly higher proportion of the deaths. Could this be, at least in part, due to their diet and possibly soya intake? Now let's have a look at some of the treatment approaches that have been proposed. So first of all, blocking the entry of the virus from docking on the ACE2 receptor. So in other words, how to avoid this spike from penetrating the cell, the host cell, through the ACE2 receptor itself. And we'll see that probably zinc has a major function here, especially in the form of zinc ascorbate and sulfate, and maybe monolaurine, which is the carbon-12 saturated fatty acid found in coconut oil. Number 2, blocking the machinery of the virus, in other words, stopping its ability to reproduce or replicate. And again here, zinc has an important role. Maybe colloidal silver could possibly have an effect here, and maybe also selenium, which has been shown to inhibit viral replication in a lot of different viruses. Number 3, block the packaging of the virus. Here we see the packaging once the virus is actually inside the cell, forming bundles before it's then shredded out through the cell and disseminates systemically. So things that could block that could be more medicinal compounds, natural medicines like Artemisia annua, cinnamon, echinacea, garlic, and pau d'arco, amongst probably many different natural remedies. And finally, 4, kill the factory of the virus, in other words, the infected cell itself, by increasing the natural killer and the killer T cells. And here we have a big role for vitamin D, vitamin K2, especially now in the black cumin seed oil as a disperser, zinc, garlic, because of its ability to increase the production of nitric oxide. So let's have a look at zinc and the ACE2 receptor, first of all. So angiotensin converting enzyme 2, or ACE2 receptor, serves as the entry point into the cells for some coronaviruses, and in this case, especially the COVID-19. It's an enzyme attached to the outer surface of the cell membranes, and these cells are mainly in the type 2 alveolar cells of the lungs, arteries and veins, heart, kidney, and small intestine enterocytes. Recent research has also shown receptors in the nasal passages and on the tongue. It's also found in the cerebral cortex, the striatum, the hypothalamus, and the brain stem itself. The expression of ACE2 in cortical neurons and glia make them susceptible to COVID-19 attack, which was the possible basis of the loss of smell and incidences of neurological deficits seen in COVID-19. The loss of smell and loss of taste are seen early in many COVID-19 patients, and it was suggested to be considered to be a heralding clue of COVID-19, which subsequently was declared. And as we know, these are typical symptoms of zinc deficiency. So here we see a couple of charts, again, of the organ expression of the ACE2 receptors: brain, nose, tongue, lungs, heart, arteries, veins, kidney, as we'll see, very important, and the intestine. So ACE2 lowers blood pressure by catalyzing the hydrolysis of angiotensin 2, which is a vasoconstrictor peptide, into angiotensin 1 to 7, which is a vasodilator. And here we see angiotensin produced in the liver and renin produced in the kidneys, go on to produce angiotensin 1, then angiotensin 1 by the ACE1, if you like, enzyme, which is zinc dependent, goes to angiotensin 2. Now, angiotensin 2 can then be shunted here with a ACE2 enzyme, which is again zinc dependent, into angiotensin 1 to 7. An alternative route is this way, from angiotensin 1 directly down to angiotensin 1 to 7. And interestingly, these two enzymes are also zinc dependent. So remember here that the angiotensin 1 to 7 is a vasodilator. So ACE2 counters the activity of related angiotensin converting enzyme by reducing the amount of angiotensin 2 and increasing the amount of angiotensin 1 to 7. It is a zinc-containing metalloenzyme located on the surface of the endothelial and other cells of the tissues just described. Interestingly, all of these enzymes are zinc-dependent. The zinc cofactor in the ACE is necessary to attach to the negatively charged glutamic acid amino acid in its structure to change the conformation of the protein from an inactive form to an active form. There was to change the actual conformation or the shape of the protein itself so the receptor can function. Here we see the receptor, and we see whole strings of different amino acids making up proteins, and these proteins have a conformation or shape to them which is altered by the change in the charge on the glutamic acid, which is negatively charged, and the zinc is positively charged. So when zinc attaches here, the protein itself changes its shape. In other words, the receptor opens and functions. Angiotensin 1 to 7 has been shown to have antioxidant and anti-inflammatory effects. It plays a protective role in the cardiomyocytes of spontaneously hypertensive rats by increasing the expression of endothelial and neuronal nitric oxide synthase enzymes, leading to augmented production of nitric oxide itself. Nitric oxide is thought to be the mechanism that the immune system destroys the COVID-19. In other words, our white blood cells, like the neutrophils, the macrophages, etc., use nitric oxide as the killing chemical. And here we see my chart of reactive oxygen species. On the right is the oxygen species, superoxide, hydrogen peroxide, hydroxyl radical. And on the left, we see the nitrogen species derived from arginine to make nitric oxide through the inducible nitric oxide synthase enzyme. And when nitric oxide and superoxide come together non-enzymatically, they form peroxynitrite, which is perhaps the most powerful of all the free radicals or reactive oxygen species to kill real bad chronic viruses, funguses, and parasites. So COVID-19 virus enters the human cell through the ACE2 receptor. Viral particles bind to the ACE2 receptor, and together they travel into the cell. These viral particles combine to a large number of ACE2 molecules, sequestering them from the cell surface and decreasing the ACE2 activity. The accompanying loss of ACE2 function can cause serious health consequences due to ACE2's participation in key physiological processes, such as regulating the blood pressure. Deficiency of vitamin D leads to an overexpression of renin, an enzyme produced in the kidneys, and consequent activation of the renin-angiotensin system, a critical regulator of blood pressure, inflammation, and body fluid homeostasis. So again, here we see renin activating the conversion of angiotensin to angiotensin 1. Loss of ACE2 function in the setting of COVID-19 infection upsets the balance of this critical system, promoting neutrophil infiltration, excessive inflammation, and lung injury. If lung injury progresses to hypoxia, the kidneys release renin, setting up a vicious cycle for decreasing ACE2 even further. In turn, lower levels of ACE2 promote more damage, culminating in acute respiratory distress syndrome, or ARDS, a severe form of acute lung injury that occurs in as many as 17% of all COVID-19 cases and can lead to respiratory failure and death. So zinc decreases and stalls viral replication. Zinc is a charged particle. It has two positives, two pluses on it, and lipid membranes do not allow charged particles to enter the cell. So zinc ascorbate zinc sulfate, when combined with quercetin, which acts as an ionophore, transits the zinc into the cell. So the ionophore carries the zinc through the cell membrane to deposit the zinc inside the cell. So zinc on its own as a charged particle cannot enter the cell membranes. Best compounds for getting zinc into the cells and to activate the ACE2 enzyme would therefore be zinc ascorbate, zinc sulfate, and quercetin. And here's our new quercetin plus zinc food supplement that we recommend. So let's have a look at the immune function role of vitamin D. It acts as an endocrine repressor of the renin-angiotensin system by downregulating the expression of renin, the rate-limiting enzyme of the renin-angiotensin cascade, and rescuing lung function, as I just described. So here we see vitamin D. Low levels of vitamin D stimulate renin, which converts angiotensin into angiotensin, the vasoconstrictor. A preclinical model of acute lung injury shows that administration of vitamin D provided protection against lung injury by increasing the ACE2 levels and decreasing renin production. Vitamin D supplementation increased A2 receptor levels, but only in conditions of acute lung injury, where ACE2 levels decreased. When vitamin D was given to control animals, it didn't increase ACE2 levels. This means that the vitamin D normalizes ACE2 levels in situations only where it is decreased. According to latest Russian research given to me by my good friend Dr. Tatiana Chernevsheva from Vladivostok, GM soy was shown to block vitamin D receptors, and it also increases the body's need for vitamin D3. Thus, there is vitamin D deficiency, and so it cannot work against the COVID-19. She goes on to say, also, I pay attention to immunoglobulin A. Assessing the health status of patients who have been diagnosed with COVID-19 and have suffered from severe and very severe symptoms, or developed atypical pneumonia, but have won through to recovery, I found out that the patient showed insufficient IgA levels in tests, as well as no diagnosis. Besides, it was noticed that doctors who showed normal and good IgA levels in the blood tests while treating the COVID-19 patients didn't catch this virus from them. It is important to keep normal IgA levels for COVID-19 carriers and COVID-19 contact persons, and COVID-19 patients with mild and moderate symptoms. Chlorella, and it's a very specific type of algae. Laboratory science shows time and time again chlorella boosts IgA secretion in the mouth and the mucous membranes. This is crucial to build our cells' ability to fight off pathogens that infect us by contacting our nose, eyes, and mouth. Supplemental vitamin D would be viable means to increase vitamin D to sufficient levels and potentially reduce the risk of complications associated with COVID-19. So here we see vitamin D. The one that we favor here is the liposomal vitamin D because it can be administered orally on the spoon or transdermally by putting the drops under the skin. Very good way of ingesting vitamin D. So vitamin D in the immune system itself first observed that all pneumonia cases have vitamin D deficiency. It was then realized that vitamin D is important for the correct functioning of the immune system. Vitamin D from the diet or from sunshine conversion of cholesterol is first hydroxylated in the liver for the storage form, which becomes the 25-hydroxy vitamin D3, and then converts to the 125 vitamin D in the kidney, and this is the activated form. This activation can also occur in many other tissues, including the white blood cells. The immune system is divided between the innate immune system, first being mediated by the phagocytes, first line of defense, but no antibodies are formed. And secondly, by the adaptive immune system, mediated by the B and the T lymphocytes, and produces antibodies, but this may take 7 to 10 days to kick in. So here we see the classification of the different white blood cells, first of all with the non-specific innate immune system or phagocytes. These are the neutrophils, the eosinophils, the basophils, the monocytes, which convert into macrophages, and the natural killer cells. And we see that most of the innate immune system, 65%, are the neutrophils. And these use hypochlorite as the killing chemical. The eosinophils use hydrogen peroxide, And the monocytes, alias the macrophages, when they're activated, they use nitric oxide. The adaptive immune system is primarily the lymphocytes. These are the B cells that produce the antibodies, and the T cells, which do the killing. So the innate immune system cells, like the macrophages, attack the virus. The 25-hydroxy vitamin D enters the macrophage and is converted then to the 125, the activated form. This then attaches to the cell nucleus and stimulates the release of certain antimicrobial chemicals. Cathelicidin, beta defensins, which are activated by NF-kappa B, these all require vitamin D3. So cathelicidin causes chemotaxis, thus increasing the immune response. It increases macrophage activity to enhance phagocytosis. It increases vascular permeability, and it increases T and B cell proliferation and their activation. Beta defenses can enter the virus cell membrane through the envelope, disintegrating the membrane. And they can create holes in the virus membrane, and the defenses can then enter into the virus and destroy it. And thirdly, they can create metabolic disruption within the virus itself. NF-kappa B plays a key role in regulating the immune response to infection. NF-kappa B is a major transcription factor that regulates genes responsible for both the innate and the adaptive immune responses. Upon activation of either the T and the B cell receptors, NF-kappa B becomes activated through distinct signaling components. The adaptive immune system, should the innate immune system not fully eradicate the virus, the adaptive immune system is activated. As I said, it takes 5 to 7 days after encountering a new antigen for the adaptive immune system to reach full activity. This leads to the activation of the T helper cells, Th1, and the Th2 immune cells. Th1 cells further stimulate the innate immune system by releasing interferon gamma. Th2 cells stimulate the release of antibodies via the B cells and are stimulated by interleukin 4 and 5. When vitamin D3 is present as the 125 hydroxy vitamin D, it stimulates the Th2 cells to activate B cells to produce the antibodies. So here we see this shuttling between the innate immune system and the adaptive immune system, and vitamin D driving the adaptive immune system more towards the Th2 status in order to produce the antibodies. Now let's have a look at vitamin K2 and the immune system. Complex signaling communication mechanisms at the cellular, molecular level are at the heart of the immune response. Vitamin K2 is a critical component that is required for both the activation and regulation of much of the cellular machinery responsible for initiating and executing our immune response. Vitamin K2 can act as a cofactor for some plasma proteins, thereby affecting immune and inflammatory responses, particularly those mediated by the T cells. Studies have found links between K2 levels and diseases, including inflammatory diseases and even cancer. Nuclear factor kappa B, NF-kappa B, and vitamin K is evidence that vitamin K can regulate the activation of the NF-kappa B pathway. Other cell and animal experiments have looked at the possible regulation of inflammation by vitamin K inhibition, or in other words, inhibition of the interleukin 6 release following endotoxin challenges. Interleukin 6 is a very pro-inflammatory chemical, so vitamin K has an inhibitory effect on the release of the pro-inflammatory interleukin 6. These researchers also found that menadine, which is vitamin K3 in an artificial synthetic form, was capable of suppressing lipopolysaccharide-induced NF-kappa B nuclear translocation and tumor necrosis factor alpha release from murine macrophage-like cells. Additionally, in the murine model of acute lung injury or acute respiratory distress syndrome, which occurs in the setting of acute severe illnesses complicated by systemic inflammation, vitamin K3 also attenuated the lipopolysaccharide-induced severity of lung injury and suppressed the increase in serum tumor necrosis factor alpha levels. This occurs concomitantly with inhibition of the lipopolysaccharide evoked nuclear translocation of NF-kappa B in lung tissue. So vitamin K2, excellent, dispersed in black cumin seed, helps to activate the different forms, K1 to K2 to K3. Now let's have a look at vitamin C and the immune system in a little bit more detail. So vitamin C, as ascorbic acid, is a water-soluble vitamin which can, when deficient, historically causes the symptoms of scurvy, which allowed the people to develop more infections, especially pneumonias, skin rashes, receding gums, and loss of teeth. Vitamin C has three functions in the body: to protect the mitochondria in the cells from reactive oxygen species produced by the electron transport, particularly those that leak between complex 1 and 3. So here we see complex 1, 2, and 3, with coenzyme Q10 being the carrier molecule to take them to complex 3 and then on to complex 4. And any leaking free radicals produced at this point, oxygen radicals, can be quenched by vitamin C. So the second function is to protect the phagocytic innate immune cells from the very reactive oxygen species they produce when they engulf bacteria and viruses. These would be the neutrophils, eosinophils, and the macrophages. The most potent of the reactive oxygen species produced by these cells is hydrogen peroxide, which vitamin C quenches very well. Vitamin C is essential, and number 3 really, vitamin C is essential in the hydroxylation first pathway in the synthesis of collagen. And here we see Linus Pauling, who discovered the actual pioneer in the structure of the triple helix of collagen. So low collagen production leads to poor wound healing, bone abnormalities, fragility of blood tissues, bleeding gums, and burst blood vessels. Most important is, of course, the collagen is the main tissue of the lungs. So let's have a look at vitamin C and its role in the immune system itself. So it neutralizes reactive oxygen species. It's an immune regulator and a cell membrane stabilizer. It distributes readily in high concentrations into the immune cells, has antimicrobial and natural killer cell activities. It promotes lymphocyte proliferation and is consumed quickly during infections, effects indicating a prominent role in the immune system regulation. Currently, there are no long-term studies available until at least September from China about the effects of vitamin C on treating the COVID-19. These trials have been carried out in China at the moment. However, there are plenty of studies about the use of supplemental vitamin C in treating influenza virus and other viral infections. We know that people who do excessive amounts of exercise are more prone to developing influenza, the common cold, and other infections, probably due to the increase in the amounts of reactive oxygen species produced in the energy pathway. Mega doses of vitamin C have been shown to prevent these from occurring. Here we see two famous British athletes, Sebastian Coe and Steve Ovett, back in the 1980s. And taking a closer look at both of these two very famous athletes, it's noticeable to have a look at both Sebastian Coe and Steve Ovett's teeth, because here we see gum disease is the first sign of ascorbic acid or vitamin C deficiency. And looking at these teeth here, when this athlete was probably in his early 20s, and again with Steve Ovett, we can see this is leading to periodontal disease, which is one of the signs of vitamin C deficiency. This is probably why these two athletes were always developing illnesses, fantastic at their racing, but were very frequently suffering from recurrent influenzas and other illnesses. A study with students where 50% of the group were given large doses of vitamin C showed that 85% of these did not get colds and influenza. In normal people, extra vitamin C only showed a small 8% benefit, but a 14% benefit in children. However, when they became sick, they then needed extra vitamin C to protect against the increased amount of the reactive oxygen species from the phagocytes and the natural killer cells. Probably of most importance, especially with COVID-19, is to protect the collagen of the lung tissue itself. So we have sodium ascorbate, vitamin C, potassium ascorbate. My preference is to use sodium ascorbate as a preventer. So with no symptoms, to take something as an immune enhancer, to use sodium ascorbate, and to use potassium ascorbate when a person actually has an infection, in this case the COVID-19, mainly because we need the intracellular potassium, which is an electrolyte inside the cells there. So another very interesting remedy is monolaurine, which is a carbon-12 saturated fatty acid derived from coconut. So monolaurine is a surfactant, that is a compound that lowers the surface tension between two liquids or between a liquid and a solid. Surfactants may act as detergents, wetting agents, emulsifiers, foaming agents, and dispersants. Soap is a surfactant which destroys viruses' envelopes. So here we see, hence, washing hands for 40 seconds while you sing happy birthday. So the soap acting as a surfactant and destroying the virus. So monolaurine from coconut is known to inactivate the lipid-coated viruses by binding to the lipid protein envelope of the virus, thereby preventing it from attacking and entering host cells, making infection and replication impossible. And again, this is handy because the COVID-19 is an envelope virus and contains these lipid-coated membranes. Other studies show that monolaurine disintegrates the protective viral envelope itself, and thus killing the virus, if you can kill a virus to begin with. So let's have a look at how we manage during an acute infection, which we may have to do somewhat remotely for patients when they actually develop an infection. So it's different stages of the disease. We start off, of course, with the asymptomatic form, of which 18% of the population who develop this are positive but get no symptoms. So these are people who carry the virus but are unaware of it because they have no symptoms. Then the mild symptoms begin, which is the fever, the cough, the gastrointestinal system, the loss of smell and taste. So in this first pathway is when we activate the innate immune system kicks in at this stage. So if mild symptoms can develop into serious symptoms, in other words, shortness of breath and a need for oxygen therapy, this is because we've got a failure of the innate immune system and the activation of the adaptive immune system coming in between the mild and the serious symptoms. And if the patient deteriorates from serious into critical, it's because we've got a failure then of the adaptive immune system itself. And this critical state will lead to the need for ventilation. And in many cases leads actually to kidney failure itself. And unfortunately, for the very few people, which is about 2 to 5%, depending on areas of the world, critical can end up in death. And this requires hospital intensive care at this stage in the intensive care units. So during an acute infection, the patient will weaken to 633 nanometer acetate in the clear. At this stage, they may have symptoms or maybe still symptomless. Obviously, it's important that the patient is self-isolating at this time, so all testing must be carried out remotely, preferably by using a surrogate, and I like to use the patient's hair as a sample. So let's have a look how to surrogate using a hair sample. You require a minimum of 6 hairs with the roots on. This is very important to have the roots because it's the root that contains the DNA. And to seal these in a small plastic polythene bag, place the bag on the patient along with the surrogate vial. This is necessary. The surrogate vial is necessary to protect the vital energy of the patient. And this is obtainable from epigenetics. So here we see the surrogate vial to protect the surrogate themselves. Here we see the polythene bag with the 6 or more hairs in of the patient along with the surrogate. So first of all, check that the surrogate now weakens to the patient's body type. So we're looking for the surrogate themselves to actually weaken to the body type of the patient. So here we see red, green, and blue different body types with the patient's hair sample on them. Obviously, it's ideal if you've got somebody who weakens to green in the clear, and then they weaken to a different color when you've got the surrogate's hair on there, the patient's hair on there. This confirms that we're actually talking about the patient's hair sample and not the surrogate themselves. So then remove the body type acetate and proceed as like treating the patient directly. Patient will be at this time in strength. Place the 633 nanometer acetate on the surrogate's abdomen. Strong muscle will weaken. So here we see, in this case, we have our hair with the 633 acetate on the top, surrogate vial here. Patient goes into weakness, the surrogate goes into weakness. 3, challenge now which meridian strengthens. So then test all the surrogate's muscles on this meridian in the clear from strength without the 633 acetate on them. Should all tests weak. So we're looking to see which meridian negates the acetate, and then we're checking all the muscles associated with that meridian. So in this case, it's the liver meridian that negates. So we test the pectoralis major sternal PMS and the rhomboid muscles bilaterally, and of course without the 633 acetate on them. Any effective remedy should strengthen all the muscles if it is 100% effective. So I insist on this with finding the right remedies, must strengthen all the weak associated muscles. My findings are: continue the patient on the vitamin D and measure the dose. The dose may go up during an acute attack, but of course we're heading into summer now, so people are getting naturally building up vitamin D from the sunshine, so the supplementation amount is probably getting less at the moment, but important when a person has an acute infection to retest. Continue the patient on the zinc ascorbate sulfate quercetin and measure again the dose. It may be here that the zinc goes up very high, maybe up to 60 milligrams of elemental zinc of each of these, giving is twice a day with food. Dr. Zerlaka from New York City recommends 220 milligrams daily during acute infection for at least 5 days. And here's the quercetin product plus the zinc, the most biologically active form for treating the immune system. Change at this stage to potassium ascorbate from the sodium ascorbate. Again, they may need 2 or more grams per day, and to do this, so 2 or more grams as a dose at least 3 times a day to now get the ascorbate inside the cell. Potassium, as we know, is an intracellular electrolyte and aids the inside of the cell to be less acidic. All positive tested COVID-19 patients have been shown to be chronically potassium deficient. Put the patient onto liposomal glutathione. If we're using the glutathione product that we produce, that's 10 to 25 mil, which will give you 800 to 2000 milligrams, 3 times a day to increase the intracellular detoxification and prevent a cytokine storm. Test the patient for vitamin K2, especially when dispersed into black cumin seed oil, and dose accordingly, and use monolaurin. We can use here the coconut with glycerin, and do this 3 times a day between meals. So just to finish off here, an interesting article from the week on the 25th of April, which is something I was concerned about myself, is the post effect of the virus. So this article is called The Long-Term Impact of COVID-19. It's becoming increasingly clear that COVID-19 doesn't just affect the lungs, raising concerns that some people who recover from the disease will be left with lasting health problems. A study of 214 hospitalized patients in Wuhan, China, published in JAMA Neurology, has found that more than a third developed neurological symptoms, including dizziness, headaches, impaired consciousness, musculoskeletal injury, and in a few cases, seizures and even strokes. These may have been a result of the virus infiltrating the patient's nervous system, but they could also have been due to their immune system overreacting. A second study found that even when hospitalized patients recover from the virus, their livers and their kidneys show signs of impairment. COVID-19 is not just a respiratory disorder. Dr. Harlan, a cardiologist in Yale University, told the Los Angeles Times. It can affect the heart, the liver, the kidneys, the brain, the endocrine system, and the blood system, all those areas of the ACE2 receptors. Separately, statistics show that 91% of people who died from COVID-19 in England and Wales in March had at least one pre-existing health condition. There was a comorbidity. However, in 86% of the cases, COVID-19 was the underlying cause of death. So please check yourself and your family daily, as the situation can change very quickly from one day to the next. I hope you've enjoyed this presentation and it will be a benefit to you, your family and your patients.
No corona, no corona. The days are getting longer, my cabin fever stronger. All due to bad spit on my couch now. I must sink in my pajamas. But when the quarantine is done, when we can gather again, as one we'll celebrate the things we took for granted all over the planet, and we will rise again, rise again, Vincere.